So here we're going to take the limit to infinity of this summation. So the first thing we're going to do is we're going to have to use our summation formulas. To do that first, we're going to have to square this part of it out. Since n is a constant up here, I'm going to factor out that 2 over n. Can do that because n's not changing and it's a certain number up here. I is changing. So this part I'm going to square out. So I'm going to square double square, starting with the last term. That would be 4 squared over n squared plus double. 2 times 1 times 2i over n is 4i over n. Square the 1. So that's what my summation comes down to. So at this point, I'm going to sum each separate term. So the summation of 4i squared over n, again, the 4 over n squared is a constant. The summation of I squared is n times n plus 1 times 2n plus 1, and that's all over 6. That's the formula for the summation of I squared. Plus 4 over n is a constant, my next term, and then the summation of I is by formula n times n plus 1 over 2. And then finally, summation of a constant is just the constant times n. So the summation of 1 would just be 1 times n. So now I have to calculate the limit of this mess. It is a mess, but it is actually very easy to do. So the limit as n goes to infinity of these rational functions. If the degree of the top and the bottom end up being the same, then you just have to take the ratio of the leading coefficients. So you're going to just imagine multiplying the 2 over n to each term. On this first term, I'm going to have, if you multiply the tops, you'll have this n times this n times this 2n, which is 2n cubed. And then I have to multiply it by this 4. So I have 4 times 2n cubed. I also have this 2 out here that I multiplied in, so times 2. So remember, this 2n cubed came from n times 2n, the leading terms of each part of each factor there. On the bottom, I'll have this n times n squared, which is n cubed, times 6, which is 6n cubed. Now, the reason I'm not worried about all the other terms, like the n to the second terms and n to the first, is because when you take the limit as n goes to infinity, you're always looking at the leading terms. So then the next term, you multiply this 2n to here, you're going to get 8, and then n times n is going to be n squared. The rest doesn't matter. And then on the bottom, you have n times 2, which is 2n squared. And then when you multiply the 2n to this n, you just get 2n over n, which is 2. So just keep in mind, what I have written in blue here is not the result of multiplying this 2 over n through. I'm just focusing on the leading coefficients because that's the only thing that's going to matter as n's going to infinity. You know that by infinite limits. So when you take the limit as n goes to infinity of all this, you're just going to have to worry about the ratio of the leading coefficients, which in this case would be 2 times 4 times 2 over 6, plus 8 over 2, plus 2. Cancel out what you can. Plus cancels there. This is going to be 4. So I have 8/3 plus 6. 6 is 18/3, so I have 8 plus 18/3, which is 26/3, which is the limit. That's all you have to do. It takes a little bit to get used to doing this, but once you get used to doing it, just do a few problems. It's really actually very simple. So that is it.